All right, guys, we are gonna do the density of a gas lab. So I'm not gonna be here, so you guys are gonna have to figure this out on your own, but I'm gonna show you what you need to do. So this lab is on page 29. And I'm gonna leave everything that you need over here on this counter. So let me just kind of walk you through how you're gonna set this up. So the first thing you're gonna get is a flask like this one. This is an Erlenmeyer flask. You need a 125 milliliter Erlenmeyer flask. And then I want you to take one of these stoppers that's connected to a tube. It's got a glass valve there and sort of a J-shaped glass on the other side. And so the first thing we're gonna do is we're gonna fill this flask with water. We don't need much, so I'm gonna take about, I don't know, 50 to 75 milliliters. Okay, so you can see that I don't have a whole lot of water in there. The actual amount doesn't matter too much. And then I'm going to put the stopper on, and in the data table we're going to record the mass of the flask, the water, and we're going to get an Alka-Seltzer tablet. So you can take an Alka-Seltzer tablet, and we really don't want a whole Alka-Seltzer tablet. That's going to be too much. So we're just going to do a fourth of one. So you guys can share these. So take an entire Alka-Seltzer tablet. I'm going to use a scoopula, just kind of use the edge of this to push down and break it in half. Okay, now I have half an Alka-Seltzer tablet, and I'm going to do that one more time. And so now I have a fourth of a tablet. You guys can share those. So I'll put that here. And I will leave this over here as well. Okay, so now I've got a fourth of an Alka-Seltzer tablet. I've got my flask and some water in it. So I'm gonna take this and I'm gonna first record the mass of this. So there's my mass before. So it says 134.87. I'm going to take this and also put it on the analytical balance, because the change that we're going to get in this lab is probably going to be pretty small. So obviously this balance over here has a little higher precision. It goes out to 4 decimal places. And so I'm going to record that mass as well. And I would just recommend that you write them both down. So this one does take a little bit of time to stop, and make sure you kind of slide all of the windows closed on this thing. Okay, so it looks like there's my mass according to the analytical balance. All right, so I'm going to take that, and then I'm going to bring that back over here, and I'm going to set up the rest of my lab. All right, so what I need next, I am going to take a 1,000 milliliter beaker, and I'm going to fill that with water. Again, the actual amount of water doesn't matter too much. I'm going to fill it about halfway. All right, then I'm going to get a ring stand and a test tube clamp. And the way I'm going to do this is I'm going to take this part and slide it over the ring stand like that. And I'm going to tighten that. And then next I'm going to get one of these glass tubes. This is called a eudiometer. And the way it works is it actually works upside down, and you fill it with water. So I'm going to take my beaker and I'm going to carefully fill the eudiometer, and I would actually probably recommend that you guys do this over a sink just in case. So we want to fill it all the way so that it overflows. All right, so it's completely filled to the top, and then I'm going to take my thumb or finger and put it over the top, and then I'm going to submerge it upside down in the water. And if I do it correctly, then I don't allow any air to get in. And so if you look at the top of my eudiometer, there are no bubbles, so it's completely full of water. I'm gonna bring that back over to my test tube clamp, and I'm gonna clamp that in. And that way it just, if you look down here, you can see that it's submerged in the water. All right, and then next, I'm gonna grab my stopper. And here I wanna slide this part of the tube that kind of makes a J. I wanna slide that up into the eudiometer. So I didn't quite leave enough space, so I'm gonna raise this a little bit. I'm gonna slide that in. I just gotta be careful not to let it come out of the water. It has to stay submerged. All right. Then I'm gonna lower that. I'm gonna let it go all the way to the bottom. Okay, so now I've got the glass up into the eudiometer. The other end is connected to the stopper. And I'm going to make sure that that fits on my flask, and it does. And so at this point, I am going to drop my Alka-Seltzer in the flask. Once the Alka-Seltzer drops in the flask, it's gonna start reacting and it's gonna create a gas. That gas is gonna go up through the glass tube, through the rubber tube, through the J tube, and into the eudiometer, and those bubbles are gonna raise up. Now, if you notice the eudiometer, the scale goes from the top down. So let's just see how that works. So I'm gonna drop my Alka-Seltzer in, and then I gotta be really quick about putting the flask stopper back on. So I drop it in, put the stopper on, and now as it bubbles, you can see those bubbles are starting to go up to the top of the eudiometer. And you can see that now we have a pocket of air that's forming at the top, and as it bubbles, that pocket of air is getting bigger and bigger. And hopefully, since I just used 1/4 of an Alka-Seltzer tablet, hopefully it won't create too much gas, and I can still measure it. If we use too big of an Alka-Seltzer tablet, we can fill this eudiometer with so much gas that it goes beyond 50 milliliters, which is the highest value that the eudiometer measures to. So we don't want to use too big of a tablet. You'll see your bubbles start to slow down. You can shake it slightly if you want to speed it up a little bit. I would wait until, I would give it several minutes. I'm not going to give it so long in this video because I'm not so worried about accuracy, because I'm just showing you guys how to do it. But in your actual lab, I would be patient, wait until it stops bubbling, kind of agitate it a little bit every so often. Not too much, because you don't want to introduce other bubbles, but you want to just make sure that the bubbles aren't just kind of clinging to the sides of the flask. Okay, I would recommend that if this was your lab, I would recommend you keep going a little bit, but I'm gonna stop. And so what I would do here is, so before I took the flask, the water, and the Alka-Seltzer tablet, now the Alka-Seltzer tablet is dissolved in here and the gas escaped. So I'm going to take my flask. I can record the mass over here on this scale again. You probably won't notice much of a change on this scale. I actually don't remember what it was before because I didn't write it down. And then I'm going to bring it over to the analytical balance. And I'll record that mass as well. And you should see a subtle change. And basically what the change that we're seeing is the gas that escaped. So it should be slightly lower. And if it is slightly lower, then that's good. And that tells us that's the mass of this bubble of air that's in here. So this is carbon dioxide that came out of the Alka-Seltzer tablet. So we can measure the volume of the carbon dioxide by reading the eudiometer. So I can see that mine is between 35 and 36 milliliters. I could probably read that very carefully as maybe 35.55 or so. This eudiometer has tick marks to the 10th of a milliliter, so I should be estimating to the 100th of a milliliter. So by doing that, I have a volume in milliliters. I can calculate the difference in mass. So now I know the mass of the gas that's in the eudiometer, and I know the volume of the gas that's in the eudiometer, which will allow me to calculate the density. Okay. The lab write-up is on the next page. It tells you what to do. So you are going to do a formal lab report. And then don't forget to answer the questions at the bottom. So when you get to so as you're going through this lab report, you've got the heading, purpose. Our purpose is to try to find the density of this gas. The experimental design is given to you in the instructions, so you can just see instructions or see handout. Make sure you include your data tables that you collected. There wasn't a whole lot of data, but make sure you put it in there. It asks you for a large diagram of the lab setup with zoomed in views of particle diagrams for the solid Alka-Seltzer and the gaseous Alka-Seltzer. So you can draw diagrams of those. And then there are some conclusion questions here, but then there are also conclusion questions here. So make sure that you are, actually I think those are the same questions. Yeah, so make sure you answer those 3 questions. Okay, if you're not sure what percent error is, you might want to Google that, and it will show you how to calculate it. Okay? All right, guys, that's the density of a gas lab. Everything you need should be over here, and you guys can do it all on your own. All right? Awesome.